Machine learning provides us with countless insights. However, you'll need to know the differences and applications of the paradigms so as to pick the most suitable. This is what our video does for you today. Make sure you stay through to the end. Supervised learning is the machine that maps an input to an output based on example input-output pairs. In supervised learning, the aim is to make sense of data available within the context of a specific question. In supervised learning, each example consists of an input and a desired output value, also called the supervisory signal. This type of machine learning allows for the model to learn over time. It is commonly used to make projections, such as supervised learning targets. This training process can be categorized into two types of problems. When data mining, these are classification and regression. An example of regression is how much sales can be made for a specific amount of revenue in a business. Regression is used to understand the relationship between dependent and independent variables. Linear regression, logistical regression, and polynomial regression are the known regression algorithms. When choosing a specific algorithm, there are some things worth considering. These include bias and variance that exist within the algorithm, as both these can throw you off the balance between too much and too little flexibility. With classification, data is assigned into specific categories by using an algorithm. Classification algorithms include the random forest, decision tree, and linear classifiers. Unsupervised learning, just like supervised learning, is another paradigm of machine learning in which users are not required to supervise the model. Instead, the model is allowed to make its own discoveries based on the pattern of information. It mainly deals with unlabeled data. For instance, a baby will likely take into detail the features of the family dog without necessarily being taught or supervised to do so. When this baby encounters another dog, based on the features of the family dog, they will be able to recognize features such as eyes, ears, and 4 legs. Here, you are not taught, but you learn from the data. Unsupervised learning allows users to perform more complex processing tasks. Algorithms associated with unsupervised learning include clustering, anomaly detection, neural networks, etc. Let's now discuss reinforcement learning. RL, or reinforcement learning, enables an agent to learn in an interactive environment by trial and error using feedback from its own actions and experiences. Rewards and punishment in reinforcement learning are determinants of positive and negative behavior. It helps in learning how to attain a complex objective over many steps. RL can be used effectively only in the following situations: when a model of an environment is known, but an analytic solution is not available; when only a simulation model of the environment is given; when the only way to collect information about the environment is to interact with it. In reinforcement learning, the actions of the agent determine the kind of data it receives. Comparing the three, we can conclude that a major difference lies in the aim of the three machine learning methods. In reinforcement learning, the goal is to find a suitable action model that would maximize the total cumulative reward of the agent. What we are saying is that any action taken by an agent in reinforcement learning is geared towards increasing rewards.
Oh, really? Speaking of rewards,
Because just as we said earlier, it is indicative of positive behavior. In supervised learning, the main aim is to calculate outcomes by making sense of the data proceed within the context of a specific question. With unsupervised learning, it is imperative of the model to discover underlying patterns and to learn from the data. The aims of the three learning methods are especially important in determining its application, which we will discuss in a bit. The second difference among the three has to do with input data. For reinforcement learning, input data is not predefined. The agent will have to discover his own methods through trial and error. Supervised learning, however, maps out input, which can be concisely used to obtain data. In unsupervised learning, the model is allowed to explore the patterns they will require. The application of all the methods will inevitably differ. Reinforcement learning is quite widely used in building AI for playing computer games and to create training systems that provide custom instruction and materials according to the needs of students. Supervised learning, on the other hand, can be used in storing biological information on human beings, as well as detecting fraud in business transactions. In contrast, unsupervised learning is useful in similarity detection and labeling unlabeled datasets. The application of all three learning methods are designed to solve specific types of problems that we will soon discuss after you click on that subscribe button. Next on, we have output differences. With supervised learning, output data systems are made known, while in unsupervised learning, the output is based on the collection of perceptions. Reinforcement learning then deals with how the agent interacts with the environment in discrete steps. Then again, all three learning methods are done to target a particular type of problem.
Let the problem solving begin.
Supervised learning deals with classification and regression type of problems, which are used to understand the relationship between independent and dependent variables, as well as to assign test data into specific categories accurately. Unsupervised learning deals with association and clustering, while reinforcement learning explores exploitation. All three methods are effective in machine learning despite the differences. It is up to you to know what works best from each method. Tell us if you have had to use any of the machine learning paradigms and how beneficial it has been in the comments section down below. We are glad to have come your way. Catch you next time.